This is my center of mass concept to prove the shape of planes, the curvature of a surface. I wrote this, I think, well, I wrote it. This I wrote today. But I came up with this proof to prove the shape of the Earth when, see, this is a while ago. At least 7 years ago, I think. And I was researching how to prove, well, the shape of Earth. And this is before Flat Earth Society, if I remember right. And I researched different methods, and there wasn't a center of mass concept at that time. Now the ones they are, I could demonstrate how to disprove their methods, but mine's the original. This is the one that actually works. It's just really hard to perform. And there's different other methods they use for gravity, in how viscosity and surface tension of a falling fluid demonstrate that if we are floating in space, then the natural surface tension of mass will form a sphere, as we know in studies done on the International Space Station, or 0G, on planes where you can drop a liquid and it forms a sphere. But that's one reason that happens, is because of pressure. In a vacuum, molecules tend to want to expand, actually, rather than form a sphere. Anyway, so if Earth is a flat plane, the center of mass is distributed evenly along the length of the surface, divided by its height, to create a, so let's say this is 1 and this is 2, then 1 probable to 2 creates a derivative to find its center of mass, and it sort of just keeps subdividing over and over again, like that sequences. I can't think of it right now. But then when you look at it like a triangle, the angle of this versus this is perpendicular to a point at the center, is a actual perpendicular pole that creates like a 90-degree angle. And this angle of gravity to center of mass versus these is all different. None of it's consistent. However, on a flat plane, it is still fairly perpendicular, but it does start to, well, it should be actually a perfectly flat plane, I suppose. It will be perfectly perpendicular, but it might angle a little bit because of other fluxes and gravitational pulses. But with a sphere, every angle of a line drawn to center of mass is even. So you can see all these degrees are equal. Now, my center of mass proof for the shape of Earth doesn't take into account an assumption of the shape of Earth. And the ancient Greek method with using the stick of shadows, I never liked that because of elevation differences, while mine seeks to pursue a constant of elevation. So you would go to an ocean or a beach at the ocean, and that gives you a very rough assessment, since the water's, going in and out. Why do I always burp when I make these videos? But because of current flow, but still you can get an average at a moment. So as the current comes in versus the current coming out, you draw a center line. Anyway, you take those 2 points, and along the ocean, along the beach, you can ideally to prevent wind resistance to tubes, and depending on how the length, so you would take droplets of water, or anything you really want to drop. I like water because you can maintain, you know where it started from, and you'll have a clear visibility of where it lands on a dry surface. And so, as water, you drop a drop of water, drop a drop of water, and this will be pulled to your center of mass, like such. Everything falls towards the center of mass, and it's, say, if Earth is egg-shaped, the center of mass is sort of going to be right there. You could draw your circle, draw it there, and then you draw various other circles to calculate, and then everything sort of averages out. But you're still going to have different angles, right? Well, as we know, due to surface tension and viscosity of water droplets form in a sphere. So we can assume that if Earth is spherical, then the ocean, covering majority of the surface of the planet and covering up the solid mass, is going to create a surface tension. And teardrops, water droplets form in a teardrop shape because of acceleration, and the surface tension isn't viscous enough to maintain a perfect spheroid. But if you have zero, or a vacuum, dropping a water droplet, it will remain a circle for the most part. There will be ripples, though. And, okay, so when you drop this, it'll splash. Splash. And if it were a flat plane, it'd be like so. But the distance here, the length of this versus the length of initiation of the drop, as opposed to this, the surface of a curved body, spherical Earth, versus a flat surface, creates two separate shapes. One being a trapezoid, and the other being a rectangle. So a flat plane, a flat Earth, flat body, will pull and mimic its own shape. Here. And a curved surface will create a spheroid. So you'd need, like, I don't know, lasers or something, because you'd have to be quite far. The curvature of the planet, the farther you get away, means that you would be drawing lines through the surface, right? And this would eventually be blinded by it. But in general, I mean, that's... Oh, another thing I'm going to forget before I say this is you can do it in an X pattern. So I don't know how to draw this one, though. So you would have your center one. Center drop there. and this would create axes. And you could do this measuring the distance of initiation of drop versus its contact surface, and you could grid this everywhere on the planet. And so doing this method, if you have a constant like water level or the ocean's level, you can grid and topographically map the entire planet sort of through center of mass. It would be a time-consuming process as opposed to how we make maps today, but I mean, holistically, it is very simple. I just don't have the money to actually perform the test, nor do I want to really care that much. I don't really see a point in worrying about the shape of Earth. It doesn't impact my life whatsoever. I just know that this is a great way to test the shape of Earth through center of mass, because whether or not you believe that the Earth is round or flat, you still believe that objects fall to the surface of Earth. So, center of mass.